Hi viewers, in continuation with the last class, the fundamentals of electromagnetic fields, introductory concepts and vector fields. I myself am Rajashekkar, Associate Professor in the Department of Electrical and Electronics Engineering. So what are the outlines of electromagnetic fields? The first one is introductory concepts and vector fields. What is electromagnetics? Basis of electromagnetics is charge. The charge is represented as a point form and all the flux lines are leaving from this point charge. What is electromagnetics? Basis of electromagnetics is charge. What is charge? A fundamental conserved property of some subatomic particle such as electron, proton, neutron. It exists because of an excess or deficiency of electrons. Electrical charge exists in discrete quantities which are integral multiples of charge on an electron. The charge of an electron is given by 1.602 into 10 power minus 19 coulombs. That is 6.24 into 10 power 18 electrons are carry a charge of 1 coulomb. On the microscopic level, charge is assumed to be continuous. Charge is always conserved. It may consisting of positive or negative form. Electromagnetics are classified into electrostatics. The electrostatics are produced when the charges are at rest. Magnetostatics. Charges are in steady motion, no time variation. Electrodynamics. Charges are in time varying motion gives rise to waves that propagate and carry energy and information. Fundamental laws of electromagnetics. There are basically four laws. Maxwell's derived four equations based upon these laws. Electrostatic field, only E field, electrostatic field. Next one is magnetostatic H field. Electromagnetic waves, both E and H fields are coupled. Fundamental electromagnetic field quantities are under electric field intensity denoted by capital E, units are volts per meter. Electric flux density denoted by capital D, units are coulombs per meter square. Magnetic flux density denoted by capital B, units are Tesla. Magnetic field intensity denoted by capital H, units are ampere per meter. A field is a spatial distribution of a quantity. It can be either scalar or vector in nature. The three universal constants are velocity of an electromagnetic wave, permittivity of free space denoted by epsilon naught, permeability of free space denoted by mu naught. C naught value is nothing but 3 into 10 power 8 meters per second. Epsilon naught value is 8.854 into 10 power minus 12 farad per meter. And permeability value mu naught equal to 4 pi into 10 power minus 7 Henry per meter. What are the relationship between fundamental quantities? C naught is equal to 1 by square root of mu naught into epsilon naught, where D is equal to epsilon naught into E, B equal to mu naught into H. Scalar and vector fields. A scalar field is a function that gives us a single value of some variable for every point in space. Examples for scalar quantities are voltage, current, energy, temperature. A vector is a quantity which has both a magnitude and a direction in space. Examples are velocity, momentum, acceleration, and force. Examples of scalar field are nighttime temperature map for Mars, geographical representation, current temperatures, contours represent surface temperature, contour lines show constant temperatures, fields are three-dimensional. Vector fields. Vector is nothing but it indicates magnitude as well as direction at every point in space. Now if you see the examples, velocity vector field, jet stream, vector fields as both magnitude and direction in space. It is denoted by a bar. Examples where vector fields are fluid flow field. Fluid is represented by a finite number of particles. Flow associated with a source, a circulating flow of particles you can observe here. Examples of vector fields, gravitational field. Examples of vector fields, magnetic field of a bar magnet which are flowing from north pole to south pole. Two different interactions are scalar or dot product. If A and B are two quantities, and interrelation under dot product is AB is equal to magnitude of A into magnitude of B, cos of the angle between A and B vectors. And this type of calculation giving the work done by a force during a displacement. Work and energy are scalar quantities which arise from the multiplication of two quantities. If A dot B equal to 0, vector A is 0. Vector or cross product. It is the product of two vectors A cross B is equal to magnitude of A and magnitude of B, sine of the angle between these two vectors. And here suffix n is the unit vector along the normal to the plane containing A and B, and this positive direction is determined as the right hand screw rule. The magnitude of the vector product of A and B is equal to the area of the parallelogram formed by A and B. If there is a force F acting at a point P with position vector R relative to origin O, the moment of force F about O is defined by T is equal to R cross F. If A cross B equal to 0, vector A is 0, vector B is 0, theta is 0. Thank you one and all for your patient listening, and please watch further videos and subscribe our YouTube channel. Thank you.